In this video we're looking at expected value. What I mean by that is, if we were to play a game, okay, like a roulette game or something like that, what amount of money would we expect to win or expect to lose in that game? Okay, so I'm just going to take this game here, and I know it's drawn pretty badly, but we have a spinner, and on half the spinner it's €1, on a quarter of the spinner it's 4, and on the other quarter it's €2. So if I spin this and it lands on if it lands on red, well then I get €1. If it lands on green I get €4, and if it lands on yellow I get 2. So let's say, and also it costs €2 to play the game, okay? So I pay you €2, pay €2 to play the game, I spin the wheel and I get €1 back. That essentially means I've lost €1. Pay €2 to play the game, I spin, it lands on yellow, I effectively paid €2 and I get €2 back, so I don't win anything, I don't lose anything. And the other one is I play €2 to play the game, I spin, it goes on green, I win €4, so it means I have a profit of 2. I want to know what my expected value is there. So I want to know how much I should win in the game. Okay, so how I do that is I take the value first. So the value, so it's €4, €2, €1. So there's the value. I'll multiply that by probability. So the probability of getting €4, which is the green, is a quarter. Probability of getting €2, the yellow, it's also a quarter. And the probability of getting €1 is a half. And over here then I'm going to look at the value multiplied by the probability. So 4 multiplied by a quarter is €1. Sorry, 2 multiplied by a quarter is 50 cents, and 1 multiplied by a half is 50 cents. The last thing I do is I add up all these probabilities and I get €2. Okay, so let's have a look at this. It cost me €2 to play and I expect to win €2. So if I was to play this game a lot, generally I wouldn't make any money and I wouldn't lose any money, because the amount it costs to play is the same as the amount I expect to win. Okay, so I hope that makes sense. Let's have a look. Let's change the amounts. Let's say I was going to win, say, €8 on the green. Okay, so €8, and the quarter of 8 is 2. So that would be €3. So now my expected value is €3. It costs €2 to play. I expect to win 3. Would you play that game? I know I would. Okay, that's because I would be expected to win money. If the expected value is more than what it costs to play, well then it's a good game to play for you. If the expected value was less than what it costs to play, then it's not a very good game for you. You should not play that game. And if the expected value is the same as what it costs to play, so if both of them are the same, then we would call it a fair game. Okay, which means no one has an advantage there, either the person playing the game or I suppose the house, okay, the casino. Right, before we go, we're going to find out if roulette in a casino is a fair game. Okay, so let's see. Right, so I'm going to look at the roulette game. Roulette, sure all of you know, it's a wheel. It has 37 slots altogether. They're all numbered from 1 to 30. Sorry, from 0 to 36. 0 being the green slot. And a simple bet would be if you walk up and you put €1 on black. Okay, so if you put €1 on black, well, if black comes up, you'll get €2. So you'll win €2. You'll get, well, obviously you'll get your own euro back, but you'll get €1. So you'll win €2. This is if I bet on black. If red comes up, if I'm after betting on black, and if red comes up, I get 0. And if green comes up, I'll also get 0. Right. So let's see the expected value on this. Right. So the amounts, €2 are the values. €2, €0, €0. The probability. Well, we have an 18 out of 37 chance, an 18 out of 37 chance, and a 1 out of 37 chance. The probability multiplied by the value, or the value multiplied by the probability. Well, this is easy. This is 0, and this is 0. And this here then is not quite €1. It's 97 and a bit cent. So if we add that, we will get 0.972, which is not quite €1, and it takes €1 to play. So, should we bet on black? No, we shouldn't. Okay, if we do, we'll probably lose over time. Likewise with red. Well, if I put €2 on red, or sorry, €1 on red, well, that means if black comes up, I get 0. If red comes up, I get 2. And if green comes up, I get 0. So, likewise again, expected value, €2 if I get red, 0 if I get black, 0 if I get green. And again, if I bet on red, the expected value is 0.7972, which is less than what I'm paying to play, so I should not bet on red either. What about green? Right, if I bet on green, if black comes up, I'm getting 0. If red comes up, I'm getting 0. And this is the payout on green. If green comes up, I get €36. Okay. So let's get an expected value. Well, in this case, we're going to get €0 if black comes up. So that'll be 0. We're going to get 0 if red comes up. But we're going to get €36. I get €36 if green comes up. Now, probability of green coming up is 1 over 37, so we multiply that by 1 over 37, and we're going to get, you guessed it, 0.972. So, no matter whether we bet on red, black or green, our expected value is always less than what we paid to play. So, based on this, if we play roulette for a long period of time, we will not win money. Based on probability, we should not win money. And that's why, I suppose, that's why there's casinos. Casinos don't want to lose money. So, I suppose that's the house's advantage. That, what is it, 3.03, right, 0.028 euros. So two and a bit, nearly 3 cents in every euro. Okay, so that's their advantage. So I suppose for every game you play, they are making, technically in probability, nearly 3 cents off you. Okay, so moral of the story, don't play. I suppose someone should have told me that a few years ago. I might have saved a bit of money. Okay, thanks lads.